Okay, let's see what we got here. I think this is the same as yesterday, but just hard version of it. You're given integer nums and two integer k and num operations. You must perform operation times on nums, where in each operation select an index I that was not previously selected. Add integer negative k to k to that value at nums at I. Return the maximum frequency of any element in nums after performing the operations. Okay, so I think this is the same. I'm going to go ahead and pull up my last answer for the medium one yesterday and see if it can just work. I mean, it's possible that the parameters of the constraints here are makes this thing too inefficient to actually be a working solution, but we'll see. I can't tell right now what the issue would be in terms of being incorrect. Okay, well, that was, I don't even know. Okay. I mean, should I try to explain this thing again from yesterday? Like, what's the point of this? It's the same problem, just I guess maybe harder constraints. I'm kind of surprised that my result yesterday was like worse than this runtime. No, I guess it was the same runtime, but it had less of a percentage compared to the average compared to other solutions. So either I used a method that was slightly higher, better optimized for a kind of longer or bigger set of inputs, but that was worse for kind of a smaller types of inputs. I don't know. Okay, so anyways, this one, I mean, I guess I'll just explain again what. So here, what was the technique again? Yeah, this is basically sliding window. Technique to count to obtain the maximum frequency. So there's basically two types of sliding windows in this one, or two different versions of it. There's going to be, okay, so I guess create an assorted array of tuples where you have tuples of value and frequency from nums array. I'll call this the tup list. And then find maximum frequency of an element where all values in the window are changed to that common value. And that first part is this one right here. So in order for it to change to a certain value that's common, the lowest value in the window needs to be at most 2k less than the highest value in the window. So in any sliding window, you have a left and right index. You can think of this almost like 2 pointers. Generally, you have a for loop that will maybe change one of those, be one of those pointers. I generally have the right pointer be the for loop variable. So for every right index in the range of indices for my tuple list, as long as left is less than right, so they're not this, left can't be bigger than right. And then the value on the left side of the window plus 2k is at most, or is within range of the value on the right side of the list. Because since this is tuples, the zero value in that, the zero index value in that is the actual value of the thing. As long as this is the case, or as long as this is not the case actually, then increment the left side of the window. So if the left side is like too far away from the right side, this means like 2k doesn't reach the right side, then you increment the left side, and before you increment the right side, you remove the count of total frequencies of values within window. You always are going to increase the windows on the right side, and when you increase the window on the right side, you'll increment or increase the count within the window. And then however many entries are in that window, then that could all be values that could be changed to the common value. So like, you know, if your low value is 5 and your high value is 10, k is, let's say, 6, then you should be able to change 5 and 10 into something that's somewhere in the middle, because, yeah, it's just possible, right? So that's one, and then the other one was going to be find max frequency of an element where all values in the window are changed to a center value that is already in the window. That is already in the window. So this one, you have a for loop that iterates through the elements, where the elements are each considered as the center. You have basically 3 pointers in this one. There's the left, right, and center pointer. The center pointer is just incrementing. Left and right just needs to be at indices where the values are within range of the center. So within k range of the center. So this one is useful because you don't necessarily need to change all the values to some common value. You can change it to just a center value that maybe has more frequency already. Like let's say there's like, in the example 2, there was like 5 11s, like 11, 11, 11, 11, 20, 20. Then you're trying to get things to become 11, so you're trying to see how many things kind of stack with that. Yeah, so you iterate through your center indices, get your center value and center frequency for the list from the center index. You move the left side of the window, you move the right side of the window, so you're closing off the left, so you're making the index on the left side be closer to the center. You're moving up the right as long as it's within range of the center. You count how many things are not at the center, so the window count is, because the things that are not at the center are the things that you would change with your operations to make it to become the center value. And then obviously you can only do num operations of that, rather than if there's like num operations, let's say it's like 5, but let's say there's like 20 things that can be moved to the center value, so you can only use 5 things. And then 5 things plus whatever the center frequency is, that's your current window kind of size, and then answers the maximum of that. All right, time complexity, this can be O of n. Oh, right. Actually, I should probably know here. Same work as from yesterday, same problem, maybe different parameters. Time complexity, this O of n for the loops to the sliding window loops. After getting the sorted array, which is sorting takes O of n log n time. So overall, this solution has speed of O of n log n. And then space complexity, this is going to be O of n for the tuple list based on the sorted array. One of the things that is most useful, or one of the really common techniques, is the sliding window technique. In general, knowing how to set that up is pretty important for a lot of these problems. Just think of it as like a left and right pointer for the most part. Think of the for loops always containing some way of making the window to have some true property. In this case, the true property is everything in the window in between the left and right pointers is within range of the center or something like that. And then counting what the window represents in terms of your answer, and then updating your answer if it's better than your answer.